Hey, Gregory Carlson here for College Algebra, and unfortunately, at the end of part 2, I made a mistake, and I bet you caught it, because you're really smart. When I did 38 times 1.1875, I accidentally typed in, I think, 1.875 or something. So this is a mistake right here. That shouldn't be 71.25. It should be 45.125. So that's a mistake right there, so please fix that. And so that means that our height, instead of being 99.6875, our height should be 73.5625. So I hope you got a laugh out of watching me make a little mistake. This is why I don't like calculators. You always type them in wrong, unless you're really, really careful. So the maximum heights the rock reached is going to be 73.5625. And that's that height value right there. Okay, let's find out now when the rock is going to hit the ground. Let's answer that part next. So what we would like to know is what is this time right here when the rock is going to hit the ground? And the way you solve that is you plug in a 0 right here. You plug in a 0 for height, because when the rock is on the ground, that means the height is 0. So essentially what we need to do is solve the equation 0 equals negative 16t squared plus 38t plus 51. So how on earth are we going to solve this equation that has a square term and a linear term and a number? Well, if you can, you should try to factor, if you can factor this and use the zero factor property. But we don't have that, and this won't factor very easily. And so what we need to do instead is something I've already taught you, which is the quadratic formula. So as a reminder, the quadratic formula is x equals, except in this case it's going to be t equals, because we're talking about time. Negative b plus or minus b squared minus 4ac, the square root of all of that, divided by 2 times a. Does that b squared minus 4ac seem familiar to you? Where have we seen b squared minus 4ac before? Oh yeah, the discriminant. That's the discriminant right there. So let me explain really quickly how this works. When this discriminant is a positive number, then we get two answers because we get plus the positive number and minus the positive number. And so we get two x-intercepts when the discriminant is positive. When the discriminant is negative, then that means we get a negative number in the square root right here, which means we have imaginary answers. And so because we get imaginary answers, that tells us that we're never going to hit the x-axis, and so we're not going to have any roots. It's just going to be imaginary. When b squared minus 4ac is equal to 0, we have plus 0 and minus 0. And so in fact, that means we're only going to have one answer, one root. And by the way, what is that root right there? It's the vertex. And if you notice, if b squared minus 4ac is 0, then all of this is 0. And what's the answer? Negative b over 2a. And what is negative b over 2a? That's the vertex. That's our special number. So you see, this is all connected. It's all connected, and it's really exciting. And so that's the connection between the discriminant up here and the quadratic formula. The discriminant is part of the quadratic formula. If it's positive, we have two answers. If it's 0, we have one answer, negative b over 2a. And if it's imaginary, if it's negative, we get imaginary, and we're not going to get any answers at all. So let's do the quadratic formula for negative 16t squared plus 38t plus 51. So plugging that in is going to be negative 38 plus or minus the square root of 38 squared. So let's do that in the calculator really fast. 38 times 38, 1444, minus 4 times a times c. Oops, you can't see what I'm doing. Minus 4 times a times c, so 4 times 16. 4 times 16 times 51 is 3264. And notice it's minus 4 times a times c. So we have two negatives, so that'll be a plus. All of that divided by 2a, which will be 2 times negative 16, which is negative 32. So that's negative 38 plus or minus the root of 1444 plus 3264 all over negative 32. So let's crunch that out really quick. 3264 plus 1444 is going to be 4708. So it's negative 38 plus or minus, and let's take the square root of that. 68.615 rounding divided by negative 32. So we're going to get two answers, t equals and t equals. So our first answer is negative 38 plus this number. So let's do 68.615 minus 38. And you get that number divided by 32. And that's going to be a negative number, so that will be negative 0.9567. And that'll be a negative number because I had this plus this, which was positive, divided by a negative is a negative. So now let's do the other one. Let's do negative 38 minus this number, which means we add them. 38 plus 68.615 is going to be 106.615. That'll be a negative number. So divided by negative 32 turns us positive. Oops. Uh-oh, I lost my number. Let me type it in again real fast. So that was 68.615. And then it's going to be plus 38. And then divided by 32. Which gives us 3.3317. So let's see if we can make sense of this. We have two answers. We're trying to find when does the rock hit the ground, and we get two answers. This is the answer right here, 3.3117. And I might have done a slight number misclick there because on my notes it says it should be 3.33. But if you round it to the tens place, this is going to be about 3.3 seconds right here. So what is this negative number? Where is this negative number coming from? Well, remember, the quadratic formula doesn't know we're doing an application problem. And if you look up here, we actually do have another intercept. And that intercept is going to be right here at negative 0.0956. So that's where that other intercept is coming from. And so we can ignore it since we're doing an application problem. All right, let's do this last part. So that's when the rock hits the ground at 3.3 seconds. By the way, this 1.1875 is going to be exactly between, because this is symmetrical, it's going to be exactly between these two roots. Not here and 0, but between the two roots. All right, the last question we haven't said is it says, over what interval will the rock be above 60 feet? So here, this line is 60 feet, so when are we going to be above this? As you can notice, this is kind of similar to finding intercepts. And so what you do is you want to say 60 is our height, so we'll plug in a 60 right there. And we want to know when is the line going to be greater than or equal to 60. So we do negative 16t squared plus 38t plus 51. And so we're going to solve this equation. 60 is less than or equal to negative 16t squared plus 38t plus 51. So first let's subtract 60. So we get 0 minus 9. And basically what we're going to have to do now is the quadratic formula all over again. Because remember, you might remember we solved one like this in a very early section, I think near the end of chapter 1. And so essentially by subtracting 60, we've moved this up 60 spaces. So now we just need to find the intercepts again. So let's do that. T is equal to negative b plus or minus b squared, and 38 squared is 1444 minus 4ac. Now in this case, excuse me, this is going to be a subtraction because we have three negatives. So 16 times 9 times 4 is 576. All divided by 2 times a. So if you crunch that out, I'm not going to do this, but if you do 1444 minus 576, and then do negative 38 plus that, negative 38 minus that, and then do divided by negative 32 for both of those, I'm not going to do it, but you get the following two numbers. You get 2.11, and you get 0.266875. So if you'd like to double check that on your calculator, go ahead. But that's how you would do it. And so that's going to be this time right here, 0.267, and this time here is 2.11. So between that interval is when the rock is above 60 feet. And so you could write that in interval notation as 0.267, comma 2.11 in interval notation. So there's a lot to unpack in this problem. First we found the equation by plugging in the values. We found the maximum height, when it happened, and what it was by plugging in negative b over 2a and solving. We found when the rock hit the ground again by plugging in 0 here and using the quadratic formula, and we were aware that it gave us a negative answer. Finally, we found out when it was above 60 by plugging in 60 here, moving the 60 over, and then doing quadratic formula one more time, and that gave us those 2 points there and there. Or there, I mean. So there was a lot in that problem. Thank you for making it through. We'll finish these last two problems in part 4.